Morning, Year 10s. Sorry I can't be with you, but look, you got the next best thing. I'm on the camera. We're following on from what we started at the end of last lesson, and we haven't written anything in our physics books yet. But can you put the title, please, Energy Stores? And can you put today's date? Miss will pause this as she needs to as we go through. Once you've done the title and date, thinking back to what we did last lesson, I wrote out this for you, but unfortunately, look, I've got it all mixed up. So elastic potential energy, this one, that's not in moving objects, that's wrong. Could you, thinking about what we did last lesson, if you write them out first of all, so write out the first column, use a pencil and ruler. It's absolutely essential that now we're starting a new book, this is your absolute best work. Remember, this is what you're going to use to revise from. That book should look like the thing you're most proud of and so neat and tidy that it's a joy to look at in the future. So definitely pencil and ruler. Put these ones in your first row, the whole first column, and then choose these ones. So for example, all of you will know that kinetic energy is in moving objects. So choose them and then fill them in. So for example, kinetic energy in moving objects would go here next to it. So you're rewriting the table in the correct way. Miss will pause now while you get that done neatly. And now Paul Borley. So the sort of thing we were talking about last lesson was this example is when I throw Borley up in the air. Now, obviously I couldn't do that inside with the ceiling there, but as the ball leaves your hand, it's given kinetic energy. I mean, that if you wanted to go back before that, it's given kinetic energy from your muscles giving chemical energy. And that kinetic energy is turned into a store of gravitational potential energy because it's moving high against the Earth's gravity. Then it starts to move back down, so it turns back into kinetic energy, and then it stops when it hits your hand, and that energy is then converted into your hand, lost to its surroundings. So for this one, Miss will pause. Can you do this exactly as that? So this is the example of a ball being thrown into the air. Miss will carry on when you're ready. And it's Borley again. So this time we've got angry at Borley, and I want you to describe the energy changes as Borley is thrown at a wall. Now I've done parts of this for you. The only bits I've left out are the types of energy. So go back to your table if you're unsure. So when as the ball leaves your hand, it has a store of something energy. When it hits the wall, this something energy is turned into a store of something as the ball changes shape. So what type of energy is that when it changes shape? And then follow it through. And when Miss is ready, she'll unpause and go on to the next one. And now 3 for you to do. So this is going to take you probably about 12 minutes. This is the important bit. Don't go for a quick, oh, the ball rolls down the hill. So the first example I want you to do for yourself, Borley is at the top of a hill and is given a small push. And the answer of the ball rolls down the hill could be told to me by a 3-year-old. We're talking about energy here. So you'll start hopefully with something like, when the ball is at the top of the hill, it has a lot of so-and-so energy. As it starts to roll down the hill, this so-and-so energy is turned into this energy. As the ball gets faster and faster, it gains more and more something energy. When the ball gets to the bottom of the hill, it's moving very, very fast because it has lots of... So I'm expecting 4, 5, 6 sentences for each one of these. That's why it's going to take you 12 to 15 minutes. Okay, you can talk to each other, you can read each other's, you can help each other. Try and do the detail, and that's the most important thing on this. This is a piece of work I actually want to mark to see that quality of you being able to use this terminology and detail. Okay, Miss will unpause when the class is ready to move on. And now, what about if Borley isn't there? What about the rest of the world? Because Borley, he'll come to lessons with me. Don't worry, you'll see him again. What about this one? So what I want you to do now is you've had a bit of time on that. You've had a bit of a chance to try it in 3 different ways. Completely different example. You apply the brakes to a lorry. And I've deliberately put the image here so you can see what's happening at the back wheels as the brakes are slammed on. Before you start writing, think about what type of energy does a lorry have to start with and how much of that would it have, because lorries are big. When you apply the brakes to a lorry, what is that energy changed into? Look at the picture. And thirdly, at the end of your explanation, when that lorry has stopped, where has all that energy gone? And then again, use the language. Use the language from that table that you did first of all. Use the language from the examples that I did. Have a look back at those if you need to. So this will probably take you about 4 or 5 minutes to do it properly. Okay, so you've got my examples on Borley, your examples on Borley, your write-up for a context I gave you, which was the lorry. Now what I want you to do is your own example. Come up with something stupid that will stick in your memory. Come up with something and draw a little picture of it. So, for example, the first thing that comes into my head is an elephant playing on a trampoline. So I can draw my elephant. Miss will be impressed with my art. It's a happy elephant. Well, of course it's happy. It's playing on a trampoline and it's trying to spread its legs out as it goes higher. Whee! Little tail. And there's my happy elephant. And it's just bounced off the trampoline. And this is what will stick in your memory when you're talking about energy. So there's my trampoline. And at the moment, the elephant is moving upwards. And I can explain the elephant's moving upwards because the elastic potential energy from the trampoline when it bounced is converted into kinetic energy, and it moves upwards, so the kinetic energy is turned into gravitational potential energy. Then it falls back down, it's turned to kinetic, then it's turned to elastic. The elastic, and then you can carry on. So my one goes round and round in a cycle between elastic potential energy turning into kinetic, turning into gravitational potential energy, and then it turns back to kinetic, then it turns back to this, and it keeps going round and round as that elephant's bouncing. Now, you are not allowed to use my elephant example. No. Think of your own example, not to do with elephants and not to do with trampolines. It can be absolutely anything. Firing a bow and arrow, shooting a gun and having your shoulder knocked out of joint. There's so many different examples. Everything's an energy change, more or less, in the world around you. So that's going to take you to draw your little picture and to do your detailed explanation. This is the most important bit. Can you think and apply what we've just been going through and what you've done so far this lesson to this bit? And last few minutes of the lesson, if we're on time. Are there any words from today's lesson and from that table that you think need to go in your glossary in the centre of your book? Are there any words in what you've written that you want to stand out from the page? And with those key ideas and key words, are there any little doodles or pictures, or do you need to draw a box around anything, asterisks, anything? Do you need anything to jump out from you when you look at it again? What are the key bits that need to stick in your memory? Okay, and I'll see you tomorrow. And don't worry, I've even planned a practical for tomorrow's lesson. Okay, thank you all very much.